Hi, everyone. Welcome to this AI Monetization Podcast, where we speak with industry leaders on what business outcomes they are using AI for. I'm Binny, the co-founder of ProjectPro. Today, we're delighted to have with us Anubhav Shrivastava. Anubhav is the head of AI at Stupa Sports Analytics, a leader in digitizing and providing prediction around sporting events. Anubhav is a 40 under 40 data scientist. He was also among the top 10 data scientists out of India. And previously, he was the head of data digital ventures at Viacom 18. Anubhav, welcome to this show.
Hi, Binny. Great chatting. Glad to be here.
Thanks, Anubhav. So, Anubhav, to begin with, we would love to hear your journey to becoming a data scientist, and specifically, did you have a long-standing interest in sport? Is that how you ended up at Stupa? Just love to hear that.
Yeah, I would say I've always had interest in sports, but just that I think, like most Indian kids, I chose academics over sports and pursued that for a really long time.
Yeah.
And I think after graduation, I started working with boutique consulting firms, largely, focused on data and AI analytics. I think in the late 2000s, AI and ML was largely not the words that you would hear. You would hear words like prediction that were more common. The tools that were around were like SPSS, SAS, and some bit amount of programming, which was largely done in MATLAB or some other tool like that. Those were largely common, and so I worked in consulting for a really long time, and then maybe after spending a decade or so in that sphere, I thought of why not explore the product side of it, because uh, AI as an application was gaining mainstream uh, application in consumer products, which prior to that, I think in the late 2000s or early 2010s was largely focused on how businesses and large companies, Fortune hundreds and Fortune 500s, were actually building that out. So I joined Viacom and was part of the founding team that actually built the digital arm of it, and focused on largely creating the data ecosystem, including analytics, and then eventually focusing a lot on AI. And yes, with Viacom, we got rights for IPL, and that's how a lot of sporting activities also started happening. We already had rights for football and other sports. And then I think this opportunity came by where Stupa was a startup and they were actually building something on the computer vision side of sports. And while I had built similar products or touched such themes in Viacom, I thought working with a startup would actually give me a lot more freedom to build things and maybe ship faster and maybe work on something that's largely focused on one theme. So I took that plunge, and it's been a rewarding experience so far.
Very nice. Before we talk a little more about Stupa, could you maybe help us understand at a high level what kind of problems were you solving at Viacom?
So at Viacom, one has to understand, the context of it. Viacom was a broadcast company, and they were planning to get into the digital streaming business. I think when I joined them in 2016, streaming was not a big business in India. YouTube was present, but there weren't enough content creators on YouTube. Netflix was present, and I think Hotstar had perhaps just taken baby steps towards it. So, and other broadcasters, I probably name Viacom, Sony, and Z, were actually thinking of getting into the business because everybody thought that smartphone is the future. And I think at that point of time, people weren't actually thinking that we didn't have 4G at that point of time. So Reliance Jio hadn't happened. So everybody was thinking it would be the smartphone as the future and not exactly TVs becoming smart, which is what is happening right now. Everyone has smart TV at their home and they're consuming the applications on TV. So it was still smartphone, and we were supposed to build digital streaming for the smartphones, you know, series, movies, because that was something that had already caught up with the West. There's a generation in the West which was referred to as the cord cutters.
Oh,
People
got it.
had cut the cable cords and had moved to digital entertainment.
Mhm.
And we somehow had the hunch that uh, India would emulate that, being such a large. I think the 4G revolution did help that a lot. But I think when I started out, my mandate was to be the custodian of the data ecosystem in the digital space, and which meant everything, right? And I think that's the good part of working in a startup kind of mode, where while your roles are not clearly defined, your accountabilities are very clearly defined. So if things get broken, you put your hand up, you take accountability of it, and you build it. So my role was largely managing the data ecosystem, getting all the data, you know,
Mhm.
when people are consuming the application, when they are actually streaming a video or streaming a series, owning that data, creating analytics out of it, and then pushing it into its meaningful conversion. And that meaningful conversion could be several, which could be, some of that data is consumed by the marketing team because they want to acquire and engage with the customers. Some of that data is, in terms of user intelligence, is very relevant for the ads team
Mhm.
or the sales team, because our revenue was largely what is known as AWOD,
Mhm.
is similar to YouTube, right? That you sell inventory for publishers to publishers in terms of showing your ads. So that was, I mean, there was two consumers. Then there was the product team, which would want to improve the product. So you do product analytics. There is tech team who would want to improve the performance of everything. So you build a data ecosystem for them so that they can query the data, analyze it, and then, later on, there were other phases to it, which is essentially building AI ML application or personalization on the
Mhm.
application. That somebody who comes to the platform actually has a personalized experience. Uh, I think around 2018, 19 is when GDPR kicked in. So I think almost for a couple of years, it took us a long time. But I think, like everywhere else on the planet, we have to ensure that data privacy takes a lot of precedence over other things.
Yeah.
And then essentially, eventually building a single source of truth
Mhm.
or for the entire org. So
Mhm.
essentially, every user, from the point he sees our ad on a digital platform,
Yeah.
to him installing our application,
Mhm.
then watching content, us creating a persona and a profile of that user, trying to retain that user onto the platform,
Yeah.
trying to upsell the subscription,
Mhm.
then trying to manage his experience to be uniform across devices.
Mhm.
So he install us on the phone, but then he watches on television.
Mhm.
And then his family members also join in. So it's just about uh, capturing every touch point of interaction with the application,
Yeah.
and essentially drawing meaningful insights that can be used by several stakeholders or one
Mhm.
stakeholder.
Mhm.
Uh, Largely, when you look at OTT platforms, the focus is on personalization, whether it
Mhm.
is personalization of how the thumbnails looks to them, or personalization of when they open up the home screen.
Right.
See, I think they were the central themes. But
Got it.
once you build that intelligence, it serves a lot of purposes.
Mhm. Got it. Makes sense. Yeah. I remember the early days of streaming. There was these early the internet speeds were just getting right, and there was some initial players slowly around us, and then all of a sudden it was just everywhere. Everybody just had it all of a sudden in just a 18, 24-month period, right? It just
Right.
took off. Yeah. Yeah.
Yeah, I think
Quite.
that
Mhm.
that largely happened because
Mm.
what happens is, when an industry evolves,
Mm.
initially there are not the this is that that particular industry is not disrupted by a lot of players across the value chain, right?
Mhm.
essentially when you, I think early way back, the point you are referring to, if one had to start a streaming service,
Hmm.
then you needed to identify a custom player, you needed to, work with the CDN, you needed to, create an application, manage front end and back end. And largely this had to be done in-house because any player who had an aspiration to build something big would
Hmm.
perhaps need something that's very stable.
Yeah.
But what happens is that once people spot opportunities
Hmm.
uh, in any industry, and then they start seeing that there are gaps
Hmm.
that can be filled, or there are these connectors kind of platform or a lot of middleware,
Yeah.
then when you see a lot of startups actually coming into it.
Mm.
And when these startups start coming into it, if you aggregate all of those services together,
Hmm.
then you can perhaps put together a business in like a fortnight.
Mm.
And that's why if somebody has to, think of setting up an OTT platform today, I don't think it should take more than 30 days,
Mm.
unless they have a very unique UX to it.
Yeah, makes sense. And at Stupa currently, Anubhav, could you help us understand? It is a very nice kind of a focus niche of sports analytics. Could you help us understand what is sports analytics? What are some unique characteristics of the problems you're solving there, and what are some of the problems to be solved in sports?
Right. I think sports analytics is not new per se. I mean,
Mm.
it's been around. So essentially, if I were to abstract it at a very simplistic level, I would say
Mm.
that just a scorecard is sports analytics, right? Is that two teams played a match and
Mhm.
which team won the match, and who scored the goal is
Mhm.
also analytics.
Mhm.
Why did the need for what advanced sport analytics came into being was because everyone, and I think largely it came from coaches, is that a good coach would know the game of his of his students a
Mm.
lot better.
Mhm.
So, for example, if you go to a coaching academy, a good coach would know which players are very good with their, the game. Let's take an example. Let's take cricket, for example.
Mhm.
Who have a better game on the front foot versus who have a better game on the back foot, and what are the weaknesses of certain players, and what are the advantages, what are the strengths of some other players, and they would largely know this because they have a good eye.
Mm.
But then that's it. I mean, that's how this information was largely stored.
Mhm.
Gradually, what started happening was that with the advent of video and matches being recorded on video format, and having the ability to go back and retrieve it, uh, as to when I got dismissed, what was the wrong thing that I was doing, and a lot of expertise coming from the commentators on field, people started realizing that okay, if you start, aggregating or capturing ball by ball information, I'm just referencing to cricket largely,
Yeah.
you can identify your weaknesses and start doing better.
Mhm.
And this, while our familiarity is largely with cricket, was also happening across with other sports.
Mhm.
So largely, this started with coaches trying to, and team staff and support staff bringing in uh, tech guys to actually, analyze and populate it with data as to, what are the strengths and weaknesses and how individual games can be improved. And then I think some of the sports which, and I would perhaps give some names like swimming or cycling, where there were more involvement in terms of scientists coming into and improving the biomechanics, and getting that advantage of performance for individual athletes.
Mhm.
It started getting trickling down to other sports. So you have, I mean, these days, and it had also to do a lot with preventing injury, right? So big sports persons with high value contracts cannot get injured a lot. So you have to take all the precautions. So I think all these things started uh, the movement for capturing a lot of data in terms of video and analysis.
Yeah.
And then what happened was that once this was done, I think some sports took the initiative to make the sport more engaging for the fans while they are viewing it remotely. So I think if you have seen some matches in the West or even in India.
Mhm.
And if you go to the stadium, you might have seen that it's the atmosphere is almost like festival-like, right?
Yeah.
But when you're watching it on television, it's largely boring unless you are in a pub and you're enjoying the moment with a group of
Yeah.
friends.
Mhm.
Just to make it more engaging to the fans, and also I think a lot of fans are also quasi or pseudo experts on the game.
Mhm.
So you give them a graphic and they'll start predicting, what's wrong, what's right, and why this is happening and why not something else is happening. So the broadcaster also picked up that as a cue that if you present a lot of graphical output to the fans on
Mhm.
on television or on any
Mhm.
streaming device, just breaking down or giving advanced analytics, it would also be very engaging for the fans.
Mhm.
Some sports picked it up and fans love it. I think we've seen a lot of that in cricket as well.
Yeah.
So, I think when we say sports analytics, we refer to this umbrella.
Mhm.
One part of it is where broadcasters are leveraging it to make it more engaging for the fans who are viewing
Yeah.
it.
Mhm.
And the other part of it is where the coaches, the team owners, and the players are actually using somewhat similar data, if
Mhm.
not more granular, because they have access to practice sessions and all that data as well to improve their own game.
Mhm.
But largely, it is driven by what we now popularly call as computer vision.
Mhm.
Um, I think the other names, machine vision, and then it's also used synonymously with deep learning also, but largely the architecture remains the same.
Mhm.
Is that you have a video and you have a continuous video, and you extract objects, their movement,
Mhm.
and you track them in real time. And that is how you eventually end up getting a very granular view at millisecond level as to what was happening with the ball in the sport, where the player was, how his movements were, and then you create uh, you know, aggregate analytics out of it, or maybe individual analytics out of it, and make it very, very engaging. So
Mhm.
for the viewer, whosoever is the consumer.
Mhm.
In terms of business, I think it has shown a lot of value in the last decade or so, and I think it is largely dependent upon how digitization and digital streaming and access to uh, those devices have actually helped. Smartphone has been a big enabler actually.
Yeah.
But this is a growing market. It's niche, but it's growing, and I
Right.
think uh, we are not far from a time where, and I think it already is. But when I'm saying we are not far from a time, I'm actually referring to a lot of sports that haven't been disrupted by analytics to that extent. Is that it would become a prerequisite that
Yeah.
unless you have a very good grasp of your strength and weaknesses aided by some form of sport analytics, you will not be able to compete with the top sports persons.
Mhm.
It holds a lot of vital value.
Got it. And in this umbrella of sports analytics that you mentioned, you have specific expertise in the image recognition, computer vision part of that umbrella, right? So, what kind of challenges does traditional computer vision face when trying to solve problems in either sports or robotics or mixed reality kind of use cases?
Right. So I would say that traditional computer vision and the way Jan LeCun actually developed it,
Mm.
uh, I think everyone knows now that there was a lot of object recognition. It was meant to read. I think we might have seen that famous video where it was recognizing alphabets on a screen, right?
Mhm.
I think every use case brings in its own set of unique challenges. So it might be tough to say that what is the generic challenge to computer vision when it comes to a lot of applications.
Mhm.
But let's say, for example, if we talk about sports in particular, I think one of the challenges, and let's take a very simple use case, which is essentially you identify a ball and you track it
Yeah.
across the frame. So what I want to do eventually is I just want to show a graphic that shows how the
Mhm.
ball over a period of time between the two players or between the team or if it's a football match. There's something very unique to sports, and there's a term for it which is called occlusion.
Mm.
Occlusion actually refers to the ball getting hidden from my view because a player was playing with the ball, right? Or a bunch of players actually were playing with the ball and the ball got hid from my view. If I'm tracking it, how to know where the ball was when it was actually hidden, right? That's that's one big challenge. Uh, Similarly, if I were to pick up another challenge, I could say just the speed,
Mhm.
right? So, for example, in a sport like badminton, I don't know a lot of people actually end up realizing it, but a top-notch badminton player can hit the shuttle for 400, 500 kilometers per hour. That's the speed.
Wow. Okay.
Mhm. And we don't realize that we actually don't get a view of it,
Right.
even when we are sitting live in the stadium and watching it.
Hmm.
If you want AI to actually spot it and track it, you have to give it enough frames to track it.
Yeah.
So you need some amount of tech there. Uh, if you don't have enough frames and some amount of prediction there as well.
Hmm.
So the speed, the occlusion, and the mere fact that when you are actually identifying an object, there is a lot of noise around it, right?
Right.
A lot of noise around it, uh, which is very similar, similar background, similar color background, different color background, but too many objects in the frame. Uh, there are a lot of objects which actually look eerily similar to the object that you want to track, right?
Right.
Somebody's shoe might look like a ball,
Hmm.
I mean, it's funny, but the truth is that if you actually start doing, and I'm not talking about today because today the technology is fairly advanced,
Yeah.
but 5 years ago when people used to pick up doing ball tracking in football, they used to say, the AI is getting confused between the football and a bald guy's head, actually.
Mm. Hmm.
So uh, they, I think largely the noise, getting rid of the noise,
Hmm.
handling occlusion,
Hmm.
and to an extent, handling the intensity or the speed of the ball, as
Hmm.
it moves around, is are the three primary challenges. The fourth one, which is largely latent, but it depends on the application,
Hmm.
is that whenever you are applying AI
Hmm.
to any any problem solving, right? Uh, a big challenge is the time the AI actually takes to generate the response.
Hmm.
Um, it might not be a problem in use cases where the expectation is not to generate the output in real time. But if the expectation is that the output has to be generated in real time, then the AI output has to beat the cutoff time that is required for your output. And that becomes a big challenge because um, a lot of models that you might actually find available uh, out of the box
Yeah.
might generate the output in the time frame that you're looking for.
Hmm.
When I talk about computer vision, and I'm just trying to move away a little bit, say from sports,
Hmm.
another application where computer vision finds a lot of usage these days is autonomous driving, right?
Hmm.
It's the form of robotics. And I know there are many, but it is one of the most critical use cases where generating real-time output is very important.
Yeah.
I mean, if there's an incoming car and you're telling me after 5 seconds, it's a little too late, right?
Right.
So generating output in real time, that's one.
Hmm.
The other thing is that you should also be able to generate the output on a low resource and low power device. And
Mm.
that's very, I think, application specific. So I'm trying to talk about robotics here a little bit. Uh, there could be a huge model, and that would be very, very precise and very accurate.
Yeah.
But the truth is that I my application does not provide me neither the resources to run such a huge model.
Yeah.
Also, I don't have infinite power. Not all applications have power connectivity all the time.
Right. Mhm,
So if I have to build something which is both uh, compatible on a low resource, on a low power device,
mhm,
and still doing the job that something would do in a lab environment
mhm.
with all the power and all the resources, then that requires a lot of effort. And I think that's one of the larger challenges, which is largely emerging because now we are trying to take all the capabilities and intelligence that we have built in the lab to a lot of real life applications. So anything that's real time adds a multifaceted challenge to computer vision problems.
Got it. Got it. Okay. And just like how in the world of text models, right, there is a category of foundation models, and then we also have many of these vertical focused models like MedPalm for healthcare and things like that, and you're able to take foundation models and fine tune it to very specific industry. Does that map towards vision kind of models as well? Are there more foundational ones, and you take that and fine tune it to specific sports if it's sports focused?
Answer to that is no and yes. For example, when LLMs or attention transformers actually started out,
Hmm.
people hadn't envisioned vision language models actually,
Hmm.
vision models.
Hmm.
But now people have started taking baby steps towards it. So
Hmm.
uh, if you research it, you will end up finding yes, there are researchers who have started working on vision transformers. It's called VIT, and there's a lot of research actually being done. So if you actively look for papers, you'll find almost half a dozen papers uh, maybe every quarter, which are
Hmm.
very vital
Hmm.
in terms of getting developed and vision
Mhm,
transformers.
mhm,
But largely, no, it's not very prevalent. Um, it's also because I think one of the early applications when it came to LLMs uh,
mhm,
in computer vision
mhm,
was to generate training data. Uh, and pardon me, I actually forgot to mention that as a huge challenge because sometimes we tend to ignore it.
mhm,
Is the fact that if I have to train, any model to detect or track any object in a video, one of the things that I need is training, right?
yeah,
Training for that object, labeling it. Labeled annotated data is what it generally refers to, and
mhm,
and I think there are billion-dollar businesses who primarily work with doing annotations. Uh, there's a dearth of it, right? So uh, imagine that you have to build. Somebody gives you a task to build a computer vision application
mhm,
on something for which you don't find any videos anywhere.
mhm, yeah,
Right? So suppose the question is this, that you are driving a spaceship and you want to avoid any meteorite hitting you,
yeah,
right? While you are behind the wheels of a spaceship,
mhm,
you don't have any videos for it, right?
yeah,
So where will you find videos? Where will you annotate the data? Where will you label the data set? So essentially, one of the usages of generative AI, which is practically fairly big, is to use generative AI to create synthetic training data.
mhm,
Could create frames, image frames. I could create videos.
yeah,
Uh, that could be trained on, uh, that could be trained on, and then the computer vision model could be trained on those data sets when there's a dearth of it.
mhm,
So that's one way LLMs are helping. There are other applications where, I mean, outside of computer vision largely, where um, say in the realm of robotics and others, where it's playing a larger role. But in
yeah,
computer vision, I would say vision transformers are still largely at uh, early stage. I would not say inception, but
mhm,
we are yet to see. For example, if you look at what Meta has built with the SAM model, right?
mhm,
SAM in terms of instance segmentation, which
mhm,
is one way to identify isolate an object. It's
mhm,
fairly good, no doubt about it.
nice.
But
Mhm,
I would still say that we are still a little far away from where we'll perhaps be saying that uh, it's as commoditized as textual or generative
mhm.
AI.
I see. Okay. And just a follow up on that, Anubhav, is that again in the world of the text models, right? The whole concept of an ever expanding context window really helps in unlocking the value of those LLMs for regular use cases. It does a similar context transfer into the vision models as well. Is the context window defined by the number of frames it can handle, and is that actually relevant to the quality of the output? A context in terms of, and is a context relevant just to that frame or a combination of frames? How is that thought about in vision?
Let me talk about it a little differently because
Sure.
if we get to context window, it might be a little different.
Okay.
So so let's say when you talk about computer vision, right,
Mm,
and you talk about say foundation models.
mm,
So what are the key characteristics, right? One of the key characteristics of a foundation model is that there has to be large scale training,
mm,
right? So the model has to be trained on a lot of data sets. So
mm,
I mean, I'm not sure if you've heard these terms, but say Coco, ImageNet, and there are proprietary data sets with billions of
mm,
images.
mm,
So the model has to be trained on them, right?
mm,
Um, the other aspect of a foundation model is that uh, it should have a lot of versatility.
mm,
So it should be able to classify objects, it should be able to detect them, it should do segmentation, and more. And without when I say, I don't essentially mean with zero shot learning, but very minimal domain specific fine tuning should suffice, right? That's
mm.
how it generally works with.
Okay.
Then when you talk about vision transformer, it's an architecture, right? So just like CNN is an architecture, it's a deep learning architecture. Vision transformer is a different kind of an architecture. So I think largely these are the characteristics of a foundation model in computer vision,
Okay.
right?
Mm,
Now, what are the famous ones that we generally know of? VIT is one. It's transformer based.
yes.
So essentially, it processes images as patches, and it's fairly good at understanding the context.
Mhm,
I'm not sure if you've seen that, but in 2012, and
mm,
probably I'll come to this after I talk about this, is that,
mhm.
and then there are other models like ResNet. ResNet
Right.
is
Yeah.
there is EfficientNet, if I'm not wrong.
Okay.
There's I think another transformer model which is called Swin, which
I see.
is a hierarchical vision transformer model. There are some others as well.
Mhm,
Now, when we talk about transfer learning with foundation models, right?
mhm,
So, what are the kinds of transfer learning? Because you mentioned about contextual window. One is feature extraction.
mhm.
Then there is fine tuning. Your feature extraction actually refers to that you have a pre-trained model and you extract features from images, right? And then you actually freeze most of these layers and you only train the final classification or whatever the regression layer you call it. But I think feature extraction is one, then fine tuning is then there is something known as domain adaptation,
Mm.
which means that you have pre-trained models, but then you make them work effectively in a domain with very limited data,
Yeah.
right? Which is, for example, something has to go in a healthcare application, and I have a general object detection.
Mhm,
So these are like this is how actually transfer learning works in foundation models, in computer vision foundation models. What I wanted to bring to your attention before we actually get into contextual window is that there's a famous paper that was written by, I think it was not a paper, but an article that was written by Andrej Karpathy, I think in 2012, if I'm not
mm,
wrong. And that was about, he took a picture of, I think, the then US President Barack Obama.
mm,
One of his staff members was actually uh, standing on a weighing machine,
mm.
and Obama was standing behind and putting 1 feet on that weighing machine. And everybody else, I think that person didn't know because he was facing the wall. Obama was standing behind, and it was actually a prank,
All right.
and
Okay.
smiling.
I might remember the picture. Yeah. Yeah. Mhm.
You might have seen that, right?
Yeah, that picture might be, yeah, vaguely familiar. Let's say describe, but yeah.
So what Andush Karpati actually wrote with that image as an example is that, has computer vision evolved to an extent to be able to decipher the meaning of that image or a frame?
Mm,
And the answer practically at that point of time was largely no.
I see.
Uh,
Interesting.
because because the truth was that while it could detect that there was a US president standing in the frame, you know, it could also detect that some other people standing, perhaps recognize all of them. But would computer vision be able to identify that it's a prank?
Hmm.
No, it won't. So, so I think that largely, and I think while that was written in 2012, even today, I would say that that largely is the case.
I see. Okay.
We have made giant strides in terms of, I think at that point of time, we were not even great at uh, identifying, extracting, and tracking an object. I think
Hmm.
we have made giant strides there. But to be able to fully understand an image like a human does,
Hmm.
uh, I think that is something that we are still far off. So computer vision has a lot of journey there to be made, and why I actually brought it up when you mentioned foundation models is because uh, I would personally, and I think a lot of people might actually differ with this, but I would personally feel that I would consider that moment to be a eureka moment when one of the foundation model arrives, or maybe not a foundation model, when
Hmm.
we can actually understand the semantics of an image in a holistic way, right?
Hmm.
You can understand expressions by looking at how wide the grin on the face is, or how what are the shape of the lips or the eyes, but understanding the full awareness of what's happening in the image, just
Hmm.
like you and I can do, is something that we are still not there.
Yeah.
To come to, I think you talked about contextual window. In Particularly in computer vision, this concept largely aligns with how a model focuses on
Mm,
regions of an image to understand both local and global relationships.
mm,
Uh, this is slightly different from how it operates in LLMs, right?
I see.
So within vision transformers, you have patch-based processing. You have, and I mentioned about swim transformers. So VITs also use swim transformers, uh, where actually what happens is that uh, the attention window actually shifts and expands, and it allows the model to capture both the fine-grained and large-scale context.
Hmm.
So let me simplify this with the intent here. The large intent here is to understand the image,
Hmm.
right? So you divide the image into fixed size patches, and you consider each of them as token, right? Now, what the transformer architecture would do is that it will compute some of these self-attention across all patches,
Hmm.
and this would effectively create a global contextual window.
All right.
So that's how it largely works in vision
Mm,
transformer. I could
mm,
talk about how it works in CNN. So
mm.
in CNNs, the concept changes to something known as a receptive field.
I see.
So so of a convolutional kernel, the uh, its receptive field actually acts as the contextual window. If I were to translate that,
Hmm.
and these convolutional layers, and they
Hmm.
progressively expand this window, which is the contextual window, enabling the model to capture broader context.
Hmm.
Uh, I mean, that's one way to superimpose the concept.
Yeah, no, this is very, very helpful just to understand there's a parallels between the
Yeah,
text models and this one. Yeah.
you could enhance it. You could enhance it further. You could have a sliding window attention. Instead of processing the entire image at once,
Mm,
you can use a sliding window that
mm,
would perhaps reduce even the complexity of the computation. You could go with something like a dynamic window. You could have, as I mentioned, global and local. So there are there are some of these things that you can do with the contextual windows. But
Okay.
I think the challenge largely with uh, contextual windows would be there would be computational overhead
Hmm.
because large window means large memory, large compute. I think particularly in real time scenarios,
Hmm.
if I have to adapt contextual window dynamically because the frames are changing, the scene is changing, it could bring its own set of challenges. If you want to learn more about it, I think there's a branch called context aware models.
I see. Okay.
You could also, I mean, to make it more relevant, you could look for
Hmm.
dynamic context aware models.
Hmm.
You'll actually find some work that is being done around that. Yeah.
Um, um, the other thing, Anubhav, we're curious about is when you're taking these models in vision into production, implementing in real use cases, right? Does the tech stack and the deployment part of it differ very differently, the MLOps part of it, in terms of observability, governance, and all of that stuff, or is it very similar?
I think the MLOps would largely remain the same.
Hmm.
The challenge with working with computer vision models in particular
Hmm.
uh, is the fact that the amount of data you are dealing with, the amount of
Hmm.
throughput you have, it is much larger you know, than otherwise with a lot of other applications.
Yeah.
So what I'm trying to say is that suppose I'm building a personalization engine
Hmm.
uh, for some application, right?
Hmm.
And I want to show that when the user lands on the home page, I want to show that user five assets or five products I want to upsell to the user. Uh, I might be using three different models behind the orchestration layer. And when the API hits me, I could use a multi-arm bandit, and that would perhaps very easily decide which model is actually performing really well, and only that could be fed back to the user or to that particular user. And I could do a lot of other things as well, right? Uh, because I might have trained that model offline, I don't need to do real-time training.
Yeah.
Even if I don't even need to do, even if it is real time, it's perhaps session level. So once I exit the current session, then there is some amount of training that happens, and then I start getting recommendations. It's very similar to that you start getting recommendations on YouTube once a session is over. I think now they do in session also. But when it comes to computer vision and a lot of real time applications, you don't have that liberty. I can't because there's a lot of throughput, there's a lot of GPU that you actually just need to run one model in real time.
Hmm.
If I were to think of having multiple GPU clusters running different models and all of them spitting out output, no, it will be very, very compute intensive. Would not make a lot of business sense. You could do that in lab environment or maybe offline. So MLOps does differ in terms of it is fairly minimalist and much more leaner.
Hmm.
Uh, I think one other area where uh, there's stark difference between when you're working with computer vision versus other applications is how you measure the model performance, right? So it's very difficult to do it autonomously. There are certain ways in which uh, essentially you need labeled data and then you can see the model output and compare uh, something known as IOU or some other methods. But uh, it still is largely starkly different from how it would work for any other model that generates text output or numerical output.
I see.
Uh, So there are big challenges.
Okay. How do you stay in touch? There is so much happening broadly in this space, specifically in your space. What are your go-to resources to stay connected to the field?
I think there are a bunch of conferences that happen every year where people publish a lot of paper. So I
Mhm.
think one is CVPR that happens in Europe every year. And also, if you keep track, if you're interested in one particular domain, then largely any big breakthrough research that actually is has hit the market, I think Google and other personalization engines ensure that you get to know about them. So that's one. I think that's largely one is you keep track of the research papers, and I think research paper these days, and when it comes to machine learning, are a little different from a lot of research papers that we used to study when we were actually growing up. So you have the model, you have the data set, you have the code, everything is available. Uh, you could review it by running it.
Mm,
Adequate at that. So that's one part. The other part is not only that, is that when you get hands on something new,
mm,
just try and adapt it or test it out yourself. Um, no matter how much you read about how a particular model is or how it is performing, whether it is good or bad, you are at least 2 degrees of separation from making any useful conclusion unless you have done it yourself, right? And third thing, which I largely feel is even more important, is that you surround yourself with people who are also very keen on
mm,
doing it,
mm,
on exploring what's happening around you, and are also not going to shy away from speaking up about an unconventional approach, even if it's not done before.
yeah,
So if you're working with a team, if you're working, with colleagues or your supervisors, create a kind of a function where people are largely encouraged to read about what's happening around, and if they can bring in a lot of uh, inspiration, or maybe transfer some of the developments that are happening somewhere else.
yeah.
Let me just take a very simple example. When I'm working on a computer vision project where there's a dearth of synthetic data, or say the dearth of data, and I know that synthetic data can be generated and it can be used to train the model. Uh, the purist in me might actually say no, no, no. It might just ruin the entire flow, and I should just rely on actual data because this has an application in real life environment. What if this goes down south? I'm not going to touch something
Yeah,
that's really new, untested.
yeah,
The other part of me would say, no, there's something new in the market on the anvil. Let's test it out. I think I generally feel also responsible there because unless practitioners test out and make deductions and observations and comments and feedback, uh, we as a society will not move ahead.
yeah.
So the onus is also on people to actually um, try out as much as anything that's, and you also should not feel, I'm not sure if you've heard those stories, but a lot of people actually talk about how LLMs killed a lot of academic research that was happening across the
Mm,
globe.
mhm,
I think one has to be also accommodative to that. That I mean, I for a really long time was working on uh, audio to text conversion.
okay.
As generating subtitles on such
Just like
models.
as a side project, is it?
No, even for work because we
Yeah, for
had
work,
the
of course. Yeah, it is why
creating
combination.
subtitles for
Mm-hmm.
for content, right?
Mm,
And we tried out this, that, and everything.
mm,
And with OpenAI, I think when they released, I'm talking about perhaps GPT-3, uh, it was great. It was comparable to any other thing that could have been built at that point of time. Had a very good, was very good even to pick up context, and one had to give it to it. I mean, I could sit in a corner and say, oh my, and a lot of research of mine is actually destroyed now. But the fact is that whatever takes you forward takes everybody forward. So
mm,
there are a lot of problems that can be solved with AI, and
mm,
if a disruption is coming along the way that is actually taking us a step ahead to where we were in the past, one has to be very welcoming of that. That I think is a primary requisite to being very inquisitive about what new is happening.
yeah. It's very well said. Be curious, keep tinkering around. Especially your point about the 2 degree separation is a very good point, right? Because unless you do a first principles bottoms up build of something, just looking at it from a top down approach, you never really understand how that thing works.
Right.
Uh, yeah, it's a very good point. Yeah. And one final question is, Anubhav, I know you're also an angel investor. What are you most excited about in this technology wave we are living through um, uh, in terms of use cases? What do you think holds the most promise for you as an investor?
I think I look at it not exactly as an AI use case.
Mm,
Um, so I don't think there's much difference between how technology has disrupted industry XYZ. I just feel that where we are right now is that AI has the potential to upskill a lot of industries by one or two step functions. Right.
mm,
So when one has to think of investing in an AI startup, and I'm just talking about AI in general, is that one has to look at two things. The thing is, if you are building something that's AI powered and that is actually elevating the industry by a step function or a two-step function, and others are not doing it, or others have not done it so far, then it will give you a head start, but just about enough head start.
mm,
The truth is that there's so much stuff that is open source, and thankful, I think, largely to Meta and a lot of other
yeah.
companies for that, is that it'll give you a head start, but that head start will not last for too long.
Mhm,
So eventually, what would survive is not the fact that you built something that is AI powered and
mhm,
that is serving an industry.
mhm,
Essentially, you building something that is serving that industry while it started out with an AI powered solution. Right. So the survivors or the companies that will eventually grow will be the ones who would solving for that use case and a lot of other use cases that are relevant to the end consumers, but not just hope that this AI intervention will take them, forward. Or for example, if they keep on adopting, AI, newer models and newer approaches, they'll
mm,
continue to thrive
mhm,
because uh, businesses survive because they're solving a problem and having, the mindset of continuing to wanting to solve that. AI is a tool,
mhm,
largely. There's disruption happening, but it's a tool. So when I think of investing, yes, the use case is important, but also what is important are the founders
yeah.
and what mindset do they carry.
Mhm,
Uh, if it is about, okay, let's talk about legal. We are solving something for the legal industry and this and that. If you're solving something for legal industry and it's giving you a leg in the room in terms of into the legal ecosystem, then don't just stop at the AI solution of it. Uh, you know, solve something for the legal ecosystem for next 5 to 10 years. If that's how you
mhm,
think of it,
yeah.
pivoting into a legal powerhouse
Mhm,
in a different way. It could be a technology legal powerhouse. Then you would survive. But just riding on the AI, I think we've seen that with the technology wave in the past, right?
mm.
A lot of
That's very
companies.
well said. Yeah, very well said. Like a inch wide and a mile deep, you need to go.
Exactly.
Yeah, yeah. It's
And
very
there
interesting.
are businesses that are actually disrupting the tech value chain with AI, which is
Mm,
essentially creating a middle layer or a connector or something that is solving for some of the intermediate steps or intermediate
mm,
business models. I think there are larger risks to that because a lot of intermediate business models don't survive. They get consumed by other players. But I think some of them have survived as well. So essentially, it's about sticking around and solving for problems rather than just using AI to hoping that it'll keep your business keep thriving, actually.
yeah, no, that's very, very insightful. Well said. Yeah. On that note, and above, thank you so much for taking time to do this. It was extremely helpful for all of us. Look forward to doing another session sometime. So thank you.
Well, it was great chatting with you, Vinny, and thanks a lot for these